Okay, welcome back. So in part 2, we're going to continue looking at the SQL language for interacting with relational databases. And mostly we're going to concentrate on select statements, but we'll take a look at some other things as well. I have bailed out of my PSQL shell. I'm going to just review how to get back in and connected to a certain database. I want to connect to the server on my local machine, so I'll just hit enter. I want to access the Postgres database, which has various tables in it. So I'll hit enter. I'm happy to use the default port number. I am logging in as Postgres, and I need to give the password. Now, I just realized when I did my install, I set a password. You can go ahead when you do your install, which I'm going to expect you to do in the homework. You can just leave the password blank, and that will make it easier for you to access the database from Python. Otherwise, you would have to put your password into your Python code, which seems rather insecure. So it's a little bit silly to have an insecure password. It's probably just better to not have a password. All right, so I've given my password, and I am now in the Postgres database. I can list the individual databases that are within my Postgres relational database system. And we've been using this MyDB database. So I want to connect to that database. /c MyDB. And now I can ask to display the tables that this database contains. If there were lots of other components in this database, I can narrow it down to just showing the tables by saying \dt. And to be clear, these are not SQL commands. These are PSQL shell commands. All right, so I am now connected to the MyDB database as shown here, and I've displayed the tables that are available. We have the INV adders table that we created and loaded data into mostly manually, but we also did some data from a file. And then the Dow 30 2018 table that we loaded in from using a program to create the table and a \copy command to copy in data, initial data, into that table. All right, so as a reminder, the SQL, structured query language statements, are divided into these 5 categories. We have the data definition language. We took a look at how to create databases within the database management system and also how to create tables within the currently connected database. I also mentioned drop, that we can use to eliminate either an entire database or a table from a database. And there are some other interactions that you can have with databases and tables as well. I showed several variations on insert commands that we could use to manually insert data into a table. You can also do deleting and updating. And at the tail end of part 1, we had just gotten into using select queries. And although there's only one command for this, it has so many options that it might as well be an entire table of commands all on its own. I'm just not going to bother getting into transaction control and security stuff. All right, so we're going to concentrate mostly on select right now. For example, we did things like selecting all of the fields, all of the attributes, all of the columns from a certain relation or table. Select star from INV adders. That table has 20 rows in it, showing ticker symbols, CEO by, and return percent. I can also select individual fields. And specify the order in which I want these to be displayed by separating different attribute names or column names from each other with commas. Okay. And I can add a where clause to filter out just those, or filter in maybe I should say, just those records that satisfy some characteristics. So here I'm saying select star, that is select all of the columns from INV adders, but only where the return percentage is greater than 10.0. All right, so these are only the high returning stocks from the ones in my table. Okay, so it is allowed to type these select commands in the forms that I've been doing, where we've been doing things in lowercase and we've just been stringing out the whole command on a single line. But the convention in SQL, especially if you're doing complicated queries, is to break select statements out onto separate lines where each line is a major component of the select. So we would typically start by saying select, and by convention we usually say that in uppercase. Then we specify our individual attributes or our arithmetic combinations of attributes or what have you. On the next line down is where we say from to indicate what table or tables we want to pull data from. And then again on the next line down is where we would put our where, and the convention is to have where in caps. So in other words, the so-called keyword parts of the select commands by convention are put in caps and put onto separate lines from each other. And so here I'm saying select ticker, return percent, and CEO by. Now, when I hit the enter key, I can just keep going typing my select command, because I'm not done typing my command until I hit the semicolon that concludes the whole command. Until I hit that semicolon, or use \G for going, that is doing the command, I can just keep typing away. And in fact, it's easy to make mistakes by forgetting your semicolon, and you type your select command, you hit the enter key, nothing happens, so you keep typing more stuff. Eventually you'll realize that you forgot your semicolon, and then you just have to start over again. All right, so I am selecting the three attributes, ticker, return percent, CEO by, from my investment attributes table, where ticker, and in this case I'm using a relation rather than an equality test. It shouldn't surprise you to learn that you can compare strings to each other for ordering in SQL just like you can in Python. So I'm going to only select the records where the ticker comes before capital M. That is, all the tickers that start with letters A through L. And let's see what we get. And there we are. So all of these are tickers where the first character is between capital A and capital L. And by default, they're just displayed in the order that they were put into the table in the first place. I can do logical combinations of different characteristics where I want to indicate which records I want to select. So in this case, I'm saying select all of the attributes. Now I am going to follow the convention that I talked about earlier. I'm going to say from on the next line down, although obviously that's optional. So I'm selecting all the fields from the investment attributes table where return percent is less than 10, and here I want to use an or, so I'm using parentheses because or has lower precedence than and. So I'm looking for records where the return percent is less than 10 and the ticker is either alphabetically less than K or the ticker is alphabetically greater than O. Now, of course, this greater than just means greater than capital O. So any tickers whose names start with O will in fact be a match, except for O itself. So if I have, OPQ, if that's a ticker, I would get OPQ as a match because that's greater than O, and so on. So now let me conclude my select statement with a semicolon, and okay, so these are all of the tickers that begin with a character that's either less than capital K or greater than, well, greater than or equal to capital O, actually, and where the return percent is less than 10%. All right. I can use a logical not, and I can also use, that's pretty sloppy. I can also use in, basically in the same way that I use in Python to check whether some value is in a collection. So this time around, I am selecting, oops, forgot my caps. Select star. I will, just to save space, do this on one line. Select star from invatters where the ticker is in one of these possible choices. Amex, UNH, Walmart, United Technologies, and it's not the case that CEO by is true. Notice a peculiarity here, which is that the SQL language does not differentiate between an equality test and an assignment, except by context. So in this case, where I'm using a where clause, the single equal sign is understood to be an equality test. Whereas if I were using the equal sign as part of my select, I would use that as part of an arithmetic expression to create some kind of variable. All right. Tick. Okay, well, fortunately, in the PSQL shell, I can just recall components of this by using my up arrow. So let me repair. Whoop, I'm going up. Okay, let me repair my typo. So that's ticker and CEO by. And it's not true that CEO by is And it's not the case that CEO by is equal to true. There we go. All right, so for all of these, CEO by is false, and I'm only getting these tickers AXP, UNH, WMT. Apparently, UTX does not exist in that table. All right, now, as I said, the order of these records is going to be the same as the order in which these things were inserted into the table. But often you would rather have things either in alphabetical order or in ascending or descending numerical order. Consequently, following the where, it's common to use an order by clause, and that's what's being illustrated next. We're saying select everything. Not select. Select everything from investment attributes where the return percentage is greater than 10. And I want to order these by the ticker. So these are going to have the tickers in ascending alphabetical order. All right, so Apple first, Boeing, Cisco, Disney, Goldman Sachs, and so on. Okay, so when you request order by, the default is ascending order, either alphabetic or numeric. Here, on slide 13, we're showing how to request descending order. We're also showing how to do a subsort. So let me type this command in. So we're saying select all records from investment attributes. Ages ago, I had a job with inventory management for a fine wine wholesaler. So I see INV and think inventory. All right, so where return percentage is greater than 10, and we're going to do an order by the CEO by. Now, CEO by only has two values, true and false, and we want these in descending order. That is, we're going to get the true ones first, and then the false ones afterward. And we're also going to then do a subsort by the return percentage in ascending order. Okay, so here we have Boeing and Apple. Those both have CEO by of true. And these others all have CEO by of false. Now, within the CEO by of true, notice that we've got the return percentages in ascending order. All right, and then similarly for the CEO by of false, the return percentages are in ascending order. We've shown how to use count to count the number of records that satisfy a selection request. We can also ask for the average, that is the arithmetic mean of a column, and the sum, min, and maximum. So here we're going to turn back to the Dow 30 2018 table, which has many, many, many more records in it. Oh, I forgot to say from. Okay, so just as a reminder, we have an entire year's worth of trading data for the Dow 30 stocks. And I'm going to say select and call these various aggregation functions. So I'm going to count the volume. I'm going to get an average for the volume. All right, so that's the average of the volume of all the stocks on all the trading days. I'm going to get a sum of the volume and the minimum volume and the maximum volume from this table Dow 30 2018. And because these aggregation functions are recognized by SQL, the aggregation function names are simply used as the column names for the resulting table. So, all right, so the count, now that's not the total count of the volume, it's the total number of records in which there was a volume, and of course that's all the records, so 7,530. Here is the average volume for all the Dow stocks for all the trading days. Here's the total volume of all the stocks for all the trading days. The minimum was less than 500,000 shares for one of these guys, and the maximum was what? 116.5 roughly million shares traded. Okay, now it doesn't really make that much sense to ask for the average volume of all Dow stocks. So I might prefer to select just Apple to get the average trading volume and total trading volume and so forth for one stock. I can use my up arrow to get back the parts of this command, and I'm going to eliminate my semicolon so that I can add a where clause. So where the ticker is Apple. This makes a little more sense and shows me that there were 251 trading days for Apple, no surprise. And the average volume for Apple is about 34 million shares per day. The minimum volume was 12.5 million shares, and the maximum volume was 96.25 million shares. Well, this raises a question now. Suppose that I wanted to get this information for all 30 of the stocks. Does that mean I have to do 30 different select commands for each one of these 30 different stocks? Fortunately, no. There is an command here called group by that you can add as, or an option for select called group by, where you can get subsets of the entire table grouped by one of the attributes in the table. So let me turn that vague description into reality. Once again, and here I'm using my up arrow again. All right, so I'm going to get the count, the average volume, the sum of the volumes, the minimum and maximum volume from the Dow 30 stocks, but I'm going to group these results by ticker. All right, so basically what this does is to split the table into subsets by the ticker field, the ticker attribute, and give me the count, average, sum, min, and max for each ticker. And there we go. Now, I should have asked for, okay, I guess in the example I also was clever enough to ask for ticker. Here I forgot, so let me redo that. All right, so I'm going to select ticker and then count, average, sum, min, max from grouped by ticker. There, that's going to make more sense. All right, so now we have these values for Apple, and then for United Health and Microsoft and 3M, etc. That's not a very convenient order, so it might occur to you to ask for all of this information. Order by ticker. So now I have the same information, but this time with the tickers ordered alphabetically. All right, so Apple, Amex, Boeing, Caterpillar, etc. Okay, now the where clause allows you to select certain rows from the select statement. So you can say where the ticker is Apple, or where the ticker starts with an A, or where the ticker, or where the where the trading date is a certain value, where the ticker is in a collection of values, all that kind of stuff. And then group by, as we've seen, allows you to subset those selected rows according to some attribute. Now, analogous to where for rows, you also have this thing called the having clause for groups. So having basically means the same thing as where, but it's for groups rather than for rows. Let me show you what in the heck I'm talking about. All right, I'm going to select ticker, count, average, min, max from my table. This time where ticker is not in Goldman Sachs, Johnson & Johnson, PG, or rats. I'm typing incorrect quotes. All right, so J&J, Procter & Gamble, 3M. Okay, so select those values from the table where I misspelled ticker again. Where the ticker is not one of these. Group by the ticker, but only show me the results having a minimum volume that is greater than 4 million shares. And furthermore, let's order these by the average volume. And by default, that's going to be in ascending order. All right. So we're selecting certain values from the table where ticker is not one of these 6. Rats, I just noticed my... Rats, I just noticed. I have a bad quote in here. This is so sad. All right. Well, this is worth talking about. I'm glad I made this mistake. So here I accidentally typed a double quote, followed by single quotes, etc. Notice that my prompt here for the shell tells me that I'm currently within a double quoted string. And it's waiting for me to type the closing quote mark. And now it's telling me, okay, I'm back in, I'm back within these parentheses here. But obviously I've totally messed up, so I'm just going to hit the semicolon, hit a closing parenthesis and a semicolon. And now it tells me, oh, no, you really messed up. So let me go back and try to clean up this disaster. All right. Select ticker count average sum, min and max from that table where the ticker is not one of these four. And I want to group by the ticker, and I only want results for those stocks where the minimum volume is at least 4 million shares, and I want to order these by average volume. All right, at long last, I've got this. There. All right, so we've only got 10 rows. Walmart, Coca-Cola, ExxonMobil, etc. The count, here we have the average volume. Notice that they are ordered by ascending average volume. That was the order by that I requested. They also all have a minimum of at least 4 million shares. Okay, and I guess it's not that shocking that the ordering of the minima is pretty similar to the ordering of the averages. Not exactly the same. Here we've got 8.9 million as the minimum, following 9.37 million, and grouped by the ticker. That is on a per ticker basis. Okay, so again, the point I was trying to make here is the where clause has to do with which rows are selected for processing. If you then use a group by, you can then do selecting within the groups rather than the rows by using a having clause as well. So the concept of where and the concept of having are both similar. You are selecting a subset, but in the case of where, you're selecting a subset of rows. In the case of having, you're selecting a subset of groups. All right, and so this is the typical or the expected ordering of these clauses. Start out with select, then from which table. Filter the rows that you want, group into subgroups if you wish, according to one of the fields. You can also then filter out certain groups and then specify your ordering, and the ordering by default will be ascending, but you can also ask for descending order. Well, all of these examples only operated on a single table, either our investment attributes table or our Dow 30 2018 table. But one of the nifty powers of relational database systems is creating joins between separate but related tables. In the Dow 30 2018 table, whoops, didn't do what I want. Okay, so in this Dow 30 2018 table, we have the ticker and the trading day. We also have the volume of trading, and then we have the high-low close, adjusted close, open prices of all these stocks. Okay? But we don't have any information about any of the corporate officers or any sales data or any of that kind of information about the, whoops, didn't mean to do that. Okay, I'm gonna reopen my PSQL shell and get back to you in a minute. All right, so we're back in action. I'm sorry about that. So here we have in the Dow 30 2018 table the date, the ticker, the volume, and various open, close, high, low, adjusted close. stock prices for the day. But of course, there's an enormous amount more that one would like to know about companies, such as who are the corporate officers, what different divisions does the company have, what are the sales for each of the profit centers within each one of those divisions, who are the employees, who are the customers. I mean, there's just, terabytes worth of stuff that one would like to know about these companies, and that can't obviously be stored in a single table, shouldn't be stored in a single table, so it has to be split up among a whole variety of different tables. Now here on slide 23, for example, I have created, or I'm showing you a piece of this officers.csv file that shows the ticker symbol and then the name of a corporate officer as well as the title that that corporate officer has. And very frankly, I did not feel like going out and getting accurate lists of who all the CFOs, CEOs, CTOs, directors, senior vice presidents, all of that stuff for the 30 Dow stocks. So what I did is I just grabbed a list of musicians from a website and I have assigned these people as the corporate officers for the Dow 30 stocks. Okay, so for Apple, we have 50 Cent as the CEO. For Amex, Alan Silvestri. For Boeing, Albert Collins. Oh, Albert Cooper is, or Alice Cooper, pardon me, is running Caterpillar and so on. So this is obviously absurd, but it does give me a chance to create a second table that does have a field in common with our stock price and volume table, namely the ticker is in common between these two tables. All right, so here is my SQL code that's going to create this table for officers. And just as we discovered with the Dow 30 2018 data, we don't have a single field in here that we can use as our primary key. Because although what I'm showing here are CEOs for these companies, they will also have chief financial officers, chief marketing officers, chief technology officers, chief investment officers. Each of these companies is going to have a lot of different officers. All right, so we are going to assume that the combination, sorry, that's bad highlighting. I'll get this right. Can't do it. So the combination of ticker name and title is going to be our primary key for this particular table. In other words, we have to have all three of these pieces of information to make a primary key. Why? Why can't we just use the ticker and the title as the primary key, for example? Well, a company is likely to have many directors, not just one. And a company is likely to have many senior vice presidents, not just one. Furthermore, some of the corporate officers of some of these companies are very likely to be directors of other companies, all right? So we have to keep track of the ticker and the name and the title to identify a unique tuple of values within this table. Okay, so now I'm going to execute this code. Of course, my files are in the users J. Ostlund downloads directory, so I will have to execute the .SQL code from downloads and also then suck in the officer's CSV file from downloads as well. Okay, so first I'm going to execute with dash I or slash I, backslash I. I'm sure I'll get this right. From users, come on, users, Jostland downloads officers.sql, and then copy in the data from the CSV file. So copy officers, this table I just created, from users Jostland downloads officers.csv, and I need to specify that my delimiter is the comma. All right, so I now have 264 rows in that officers table. I can say select. All right, I'm going to try to be consistent with my style. So select star from officers. That's all of the records. Jimi Hendrix is a director of American Express. That's pretty cool. If I want to know all of the officers of Apple, all right, I can say select star from officers where ticker is Apple. And here we have the officers in this table for Apple. All right. Now, here's where I'm showing a join. That is, I'm joining together the ticker fields of the two tables. I'm not using the .30 table. I'm just using the investment attributes table here. I'm going to select the inv-adders ticker as ticker. Okay, now you very likely don't remember by now, but if we want to specify a different label for a column than the specification that we've used to access that column, we say as some name. And in this case, because I'm using two different tables in my select statement, I'm prefixing each attribute with the table that it comes from. All right, so select from the investment attributes table the ticker, and just call that ticker. Also select from officers the name field, and we'll call that as CEO name. Why CEO name? Well, I'm going to use a where clause to only select the CEOs. All right, so I'm going to get the name from the officers table and label that field as CEO name. I'm also going to obtain the CEO by field from the investment attributes table. I'm accessing, of course, two different tables now. So from has to list both of those tables that I'm accessing, in investment attributes and officers, where the title of the officer is CEO, and I'm indenting here just for style, officer's ticker is the same as investment attributes ticker. Okay, cool. So So I'm accessing two tables here, and from those two tables, I'm going to display three fields of information. I'm going to display the ticker symbol as ticker. I'm going to display the name field from the officers table as CEO name. I'm also going to display whether the CEO is or is not currently buying stock in the company. I'm getting this information from two different tables, investment attributes and officers. And I'm selecting the rows where the title of the officer is CEO, and also, I said offers, that's not right, officers ticker is equal to investment attributes. So that's joining these two tables together on the tickers field. And now, here we are. All right, so these are the CEOs of the companies with the CEO by value. Okay. Now, there are actually 20 companies in my investment attributes table. Right? So it must be that I did not specify a CEO for one of those 20 companies. And that's why I'm only getting 19 matches for the tickers for 19 companies, the CEOs for those companies, and this indicator as to whether that particular CEO is or is not buying stock in the company. All right. Select Into allows you to not only select certain records, with group by and order by and having and all that good stuff, but instead of having the table appear on the screen, we can have the resulting table be written into a brand new table. By the way, I neglected to mention, but this is a feature of relational database management systems, that what you have are tables, all right? Now I have three tables, Dow 30 2018, investment attributes, and officers. And each query that I do results in a table. Okay, so when I do a select from INV adders, what I get is a table. It has attribute names, and then it has values for the records from that table. The same thing is true if I use a where clause. So if I say select star from investment attributes where ticker is in J&J INTC DIS. Okay, so select some columns, select some attributes from, well, all attributes, from the investment attributes table where ticker is one of those three tickers, and the result that I get is a table, or technically in strict relational database terminology, this is a a relation. I forgot the word again. And I also see I made a spelling mistake. That should have been DIS rather than DIX, which is why I only got 2 rows. Okay, but the deal here is that I can use the into clause to specify that I want the result to go into a permanent table in my database rather than just onto the screen. So let me do this example on slide 27. I'm going to say select the date, the ticker, and the closing price into a new table, Apple Close, from Dow 30 2018, where ticker is Apple. All right, so I'm getting a subset of tickers, only the records where ticker is Apple. I'm also getting a subset of attributes. Whoops, not data. That should be date. Oh, rats. Well, okay, so this is going to fail. Ticker equals Apple. All right, and I got an error, but that's okay. I'll just use my up arrow to fix it. All right. I forgot to say into. I'm going to hit Control C and up. No. Rats. I forgot, and this is something you should be aware of, that when you hit Control C, it doesn't just interrupt the current SQL command that you're typing. It actually kills the PSQL shell itself. So I'll get that back in a moment. Okay, back again. So I have connected to the MyDB database, and I have displayed the tables available in this database. And we did not yet successfully create this Apple Close table. So let's do that, and I will not make a typing mistake this time. So here's my select date, ticker, close into Apple Close from Dow 30 2018, where ticker is Apple, and yes. So we selected 251 rows because that's how many trading days there are in the year, and so we got all of the Apple tickers. And if I now ask for a list of tables, I display my tables, and now I do have Apple Close. So if I say select star from Apple Close, I get just those three attributes, date, ticker, and close, for every trading day of 2018. Okay. And here I'm using a where clause. There isn't really anything new going on here. I'm just saying let's only look at the first 2 weeks, more or less. So where date is less than 01/15/2018. Okay, so that was a demonstration of how to do a query and store the result of the query into a new table in your database rather than having that table just appear on the screen. Finally, this last example shows how to take a table that's defined inside of your database and copy that to a CSV file on your disk. So let's do that last one. I'm going to, well, I can just type the name of the, I'm going to say /copy the Apple Close table to users J. Ostland downloads Apple close.csv. And I want, this is a CSV file, and I'd want a header to be put into that CSV file. If I don't say header, I won't get the header. I'll just have data in there. And although on input, the copy command is not smart enough to understand what the delimiter of a .csv file is, on output, if I say that this file is a CSV file in all caps, well, I don't need the all caps actually, it is clever enough to understand that that means that there should be commas in between the output fields. And there we are. And let me just quickly pull up an ordinary shell. Okay, so this is a utility called Cygwin, which gives me a Linux-like terminal for my Windows machine, and I can say I'm in the FC3 Mini 3 2019 directory. I can just go up one level and then down to downloads, and in here is my Apple close.csv file, and there are the contents. Okay. I've got the date, ticker, and close for every trading day of 2018. All right, well, that gets us to the conclusion here. Now, obviously, there's a great deal more to know about SQL than we've had time to talk about in a few hours. But if you, as I understand it, for interview purposes, you will mostly be asked about select statements, because as a quant, you are typically not going to be well, you may, depending on your role, but typically somebody else is the database administrator, and somebody else is responsible for setting up and organizing the databases and the tables within the databases and so on. And as a quant, what you're mostly doing is extracting information out of these database tables in order to do analysis. Okay? And you may occasionally also be putting data back into the database. But the primary thing to be aware of and practice with is select statements. And I am told, but I have... I could be wrong. I am told that they want to make sure that you understand what the group by clause is about. So remember that you use where to select rows, group by to subset those rows according to some attribute, and then having is the equivalent of where, except having is for the groups rather than for the rows. Okay, we'll call it quits there.